So now, so to be nationally recognized among the best institutes in India for the excellence in technical education. This is our institute mission. Then the vision of the institute, that is vision of the institute. Then mission is to impart the value-added technical education through the ambience of academic excellence, research and life skills by inculcating personal touch and respect in the relationship amongst the stakeholders. Okay. So these are our institute vision and mission statements. Okay. So next is the departmental vision and departmental mission. So the departmental vision, if you see here, it is to be nationally recognized for excellence in education, strengthened with innovation, research and industry institute interaction in the field of civil engineering. Okay. This is our departmental vision. Then departmental mission is to impart the value-added technical education through the ambience of academic excellence, applied research and consultancy by inculcating personal touch and mutual respect. So this is the departmental vision and the departmental mission statements. And now these are the POs, that is the program educational objectives. So there are 5 POs, as you know. You are knowing all these POs already. Okay, so this is our first PO. That is, if you graduate from the institute, then what are the things or what is expected, that is given over here. Okay, it has POs produced. So the Department of Civil Engineering has its POs to produce graduate who. Okay, so the graduate who functions successfully. Okay, so the function successfully in a professional environment through use of appropriate technology towards holistic development. Okay, holistic development, and then ruler with the consideration of safety, sustainability, economical feasibility and environmental impact. Okay. So this is your first PO. Then second is this one, demonstrate leadership and professional ethics. So you can read here on the screen. This is your second PO. This is the demonstrate strong and demonstrate strong communication in the society. So this PO is related to communication. Okay, your communication, it may be oral communication, it may be communication through the drawings, that you should be able to do. Okay, engage in enrichment of the knowledge and skills through the lifelong learning. Okay, and the last one is the demonstrate. Just 1 minute, I will clear all these things. So the last thing is demonstrate a sense of ethical and societal responsibility in various sectors such as water supply, sanitation, transportation, irrigation, food control, etc. Okay. So these are the program specific outcomes, okay, and these are the POs. You know that there are 12 POs. So this is the basic initial information. The important thing. So you should write down these COs. Okay. What are the COs? So in between today there is a network problem. So if it gets disconnected, try to rejoin. Okay, I am facing some problem in the connection. Okay, so now here your first CO CV 421.1. What the first CO says? It says that upon the successful completion of the course, student will be able to, okay, then first able to design dog-legged and open well staircases. Okay, so you can able to design, you should able to design the dog-legged and open well staircases. Then after that, uh, second CO says that to design square, rectangular and eccentric footings. Okay, So you should be able to design the square and rectangular footings. And third CO, what does it say? Analyze tendon profile and various systems of pre-stressing. Okay, you should be able to analyze the tendon profile, that is, it comes under the pre-stress. Okay, and various systems of pre-stressing. Then fourth CO, CV421.4, to analyze losses in pre-tensioning and post-tensioning pre-stressed members. Okay. Then fifth CO is design pre-stressed girders and end blocks. And sixth CO is design retaining walls and RCC water tanks as per IS code. Okay. So these are the 6 COs. So this, okay, I think the screen is visible to all of you. So the syllabus for design of concrete structures 2, okay, DCS-II. So here you will see this course objectives are given, course outcome is given. So this is, here you can see this unit number 1, staircase, design of staircase by limit state method. Okay, so here we are going to design the staircase by limit state method. Okay, so by using limit state method, design of staircase will be there. In this unit, if you see the syllabus, design of staircases, types of staircases, uh, then design of simply supported and dog-legged staircase, open well staircases. Okay, so in the examination, design you will get the design of that dog-legged staircase and open well staircase. Out of these two, any one will be there in the examination to design. Okay, so here we will see when we are designing the staircase, how to design the open well staircase and how to design the dog-legged staircase. Okay, then your second unit, that is column footings. So here design of isolated square and rectangular column footings subjected to eccentric load. Okay, so only square and rectangular column footings we are going to design. Okay, and that to design of isolated. Here if you see, here it is given as isolated. Okay, so only isolated footings we are going to design. Isolated means single footing for a single column. Combined footing is not there. Isolated means what? If you see here, suppose now this is a column. Okay. This is a column, and below the column we are going to place the footing. So the footing may be like this. Okay, so this type of footing will be there. Okay, so this is your column and this is your single footing. Okay, this is your footing, and for a single column a single footing is there. So this is called as isolated footing. Okay, only this is your footing area. Okay, the footing area. So for the single column, single footing is there. That footing is called as isolated footing. So isolated square and rectangular footing, that design we are going to see over here. This is called as the depth of the foundation. Okay, depth. Then here on this side, width will be there. This may be length, or you can say this is length or this is width. It doesn't matter much more. Okay. So now this is isolated footing. Then next thing is unit number 3, next unit. So in this unit you are going to design analysis and design of cantilever and counterfeit retaining walls. Okay, analysis and design of cantilever and counterfeit retaining walls. So in this unit now we are going to design the cantilever wall, retaining wall and counterfeit retaining walls we are going to design over here. How to design the retaining wall, how to consider the active earth pressure, how to consider the passive earth pressure. You know that there are basically two types of earth pressure. First is active and second is passive. Okay, So retaining wall, this structure is used to retain the soil. Okay. So how to design these types of walls, that we are going to see in unit number 3. Okay. After that, unit number 4. In unit number 4, design of water tanks is there. Then design criteria, permissible stresses, design of circular and rectangular water tanks. Only circular and rectangular water tanks are there. Okay, and GSR. GSR means what? Ground storage reservoirs. That is GSR. Okay, ground storage reservoir. So only GSR is there. So this we will take this chapter at the end. Water tank chapter is at the end. Okay, we will take first 3 units, and then we will move to the 5th, 6th, 7th, 8th, 9th, and at the last we will take this unit. Okay, water tank. So now after this, your next unit is, this is your unit number 5. Introduction to prestressed concrete concepts, systems, and methods of prestressing. Okay. So, what is prestressed concrete? That we are going to see over here. Then, what are the different concepts of the prestressing, and what are the different systems and methods of prestressing? Okay. So that we are going to learn here. Right now, I am not going into the detail of anything, because when the unit starts, you will automatically know what we are learning. So right now, for the time being, just I'm telling you the brief, in a brief, what is there in the unit. So I think this prestress term is new to you. You may heard this term prestress. So we are going to see this in detail. Then your next unit is unit number 6, analysis of symmetrical and unsymmetrical section, thrust line, and cable profile. Okay, so symmetrical and unsymmetrical sections means what? Rectangular sections are the symmetrical sections. Okay, suppose now if I draw this rectangular section B and D, it is symmetrical. If I draw the I section, okay, I section, then this is also symmetrical. Okay, this I section is also symmetrical. But if you draw the T section is not a symmetrical section. This is unsymmetrical section. Okay, likewise, we are going to deal with symmetrical and unsymmetrical sections. Thrust line and cable profile, that is cable, and cable means what? A wire is there like this, steel wire, and in that number of steel bars are inserted. Okay, a cable may consist of 10 bars, 5 bars, 6 bars, 8 bars, whatever it may be. Okay, sometimes in the prestressed concrete, for bar, a word used is tendon. Okay, in the DCS-I we always say that 10 mm bar, 20 mm bar. Okay, so in this prestressed concrete, instead of bars, we use the word tendon normally. So now after this, then the unit number 7. So for the unit number 7, losses in prestress, pre and post tension members. Okay, so what are the pre-tension members, post-tension members, that we will already learn in unit number 5 and 6. Now in unit number 7, losses. While transferring the pre-stress, there are some losses occur. So basically these losses are divided into two categories. First is pre-tensioned losses. Okay, first is pre-tensioned losses, and second is post-tensioned losses. Okay, post-tension losses. So in these two categories, this is number 1, this is number 2. All the losses we are going to see. What type of losses will happen in pre-tension members and post-tension members. Okay. Then after this, unit number 8, design of rectangular and symmetrical I sections. Okay. So here the design of rectangular sections we are going to see, and I sections. Okay, only the symmetrical I section is there. So here this is the now up till now in DCS-I what you have learned. You have learned the design of rectangular beams. Okay, design of T beam, design of L beam. These things you have already learned. Now here you are going to see design of rectangular beams and this I beams. Okay, that we called it as a girders because normally pre-stressing is used for high span. Okay, to increase the strength. So this is the design of rectangular and symmetrical I sections that we will cover in unit number 8. After that, unit number 9. This is the last unit. So in this analysis and design of end block by various methods, stress concentration. So we are going to see how to analyze and design the end blocks. End blocks means what? Now I will tell you in short what is end block. Suppose now this is a beam. The depth of the beam is D. Suppose D is the depth of the beam. Depth of the beam. And now this portion is nothing but L, length. Length of the beam. So end block means what? Whatever may be the depth of the beam. Say it is 500, 600, 800, whatever may be the depth, or 450, 400. You should take that much distance along this span. So from here up to a distance D. Okay, whatever may be this portion of the beam is there. This portion. This is called as end block. This is called as end block. From this side also the similar thing is there. Suppose D is distance D is up to this point, then this portion, whatever is the portion remaining, this is called as end block. Okay. So now in pre-stressed concrete, there are several other stresses are developed. Bursting stresses are developed at the end. Okay, horizontal bursting stresses, vertical bursting stresses. Okay. So bursting, I will write here the word. Okay, bursting forces and bursting stresses are getting developed at the end. So how to analyze those? That we are going to learn in unit number 9. Okay, so these are the 9 units which we are going to see one by one, and after that here you will see this. Only IS 456 2000 shall be allowed in university examination. So now you know that already for DCS-I you have used this. Then in term work 10 design assignments on above syllabus. Okay, so you are having the assignments on each unit. You need to solve the assignments. So this is the list of reference books which is given over here. So in this reference book, this is second number. Reinforced cement concrete BC Punme is also good. Then reinforced cement concrete Jain volume 1 and volume 2. This is also a good book. Okay, you can refer these two. And for pre-stressed concrete, that is your for section number 1, you can use these two books. And for pre-stressed concrete, this N Krishna Raju and then Ramamrutam is also there. Here that name is not mentioned. So Ramamrutam book is also there. You can use that book also. Okay. So this is the overview of the syllabus. Okay. So the syllabus, although it is one-liner syllabus, but it is we need to cover the many things in this. Okay. So now for today, I will tell you the basic things about the staircases, design of staircases, column footings. Okay. So before going to our unit number 1, let me tell you few things. Now DCS in the DCS-I, you learn how to design the beams, how to design the slabs, then how to design the beams for shear bending and torsion, and design of columns, and what is the limit state method. Now here design of staircase is there. After that design of footing is there. So while designing the staircase, we are generally design the staircase. The slab of the staircase is like a one-way slab. Okay, we generally design the slab of the staircase as a one-way slab. Now you know what is one-way slab and what is two-way slab. I am not going into the detail of one-way slab and two-way slab. Okay. So, but the thing is that when we are designing the normal one-way slab, the slab is perfectly horizontal. Okay, the slab is perfectly horizontal. But see, when we are designing the staircase now, the slab is not perfectly horizontal. Okay, are you getting it or not? I don't know. So I will draw the diagram over here. So suppose now here this is the slab. Okay, I will draw here. Okay, and then the further portion is landing. This type of staircase may be there generally. Okay, just to understand, I have not drawn it perfectly. So here, if you see the steps, then the steps are somewhere like this. I will draw it manually. So steps are like this. Okay, whatever may be the number of steps, we will draw here. So these are your steps. So this is your tread, and this is the riser, and this is the slab. This is called as west slab of staircase. Now, if you see this slab, this is not horizontal. If you see over here, it is inclined at an angle theta. It is inclined at an angle theta. So we need to take the, what we can say, if you calculate the weight horizontally, if you calculate the weight of horizontal slab, that is, if we assume that this slab is not inclined, it is perfectly horizontal like this. Okay, and if we calculate the weight of this slab which is horizontal, then we need to transfer this weight to this inclined position. Okay, so here the again resolution comes into the picture. Again, sin theta, cos theta, we need to take into the account. Okay, so this thing, we you must, what we can say, understand while designing the staircase. Okay, so I think we will go through the staircase now. We will start with this, our unit number 1, that is the staircase. So before moving forward, today how many? 39. Okay, so the attendance is low. Still, we will begin with. We will cover the initial things of the staircase. So here I will write unit 1, staircase. So this is very easy to design the staircase. Okay. So here first of all I will write what is the syllabus of this. You also note it down. Okay. So your syllabus is design of staircase, design of staircase, then design of staircase, then terminologies, then terminology, then after that design of dog-legged staircase, design of dog-legged staircase, then open well staircase, open well staircase. Okay, so this you are going to see in this unit. This is the syllabus of the unit. So now the book recommended for this is you can use Punmiya or Jain, AK Jain. Okay, both the books are good for this. So now the next thing is we will see some basic things about the staircase. Okay, so first of all the introduction. So here I will write introduction. I hope you are also noting down these points. These points are important. Okay, so introduction. So staircase I will write and then I will explain. Staircase consists of steps steps arranged in a series arranged in a series arranged in a series for the purpose of for the purpose of giving access giving access to different floors to different floors of a building. Different floors of a building. Full stop. The location of stair requires good and careful consideration. Okay, so here see stair consists of steps arranged in a series for the purpose of giving access to different floors of a building. Okay, so this is normally the stairs which we see normally if we will draw in a line diagram. So these types of steps will be there. Okay, so I will draw here correctly. Normally these types of steps are there. Okay, and here your slab is there this way. So these are the steps and here is the slab. So these are nothing but your steps and this is nothing but slab. So we are going to design this slab of the staircase and we are going to calculate the number of steps also. Okay, just 1 minute. So there are some terminologies which are used in the staircases. Different terminologies are there. So we will see what are those. So the first definition is of trade. What is the meaning of trade? That we are going to see over here. So trade, it is the horizontal upper portion of the steps. Okay, trade is nothing but it is the horizontal upper portion of steps. So it is the horizontal upper portion of the step. So now if I draw the staircase, so this is the slab and now these are the steps. So this is called as trade T. This is called as trade T. Okay. So I will dictate once again. Trade It is the horizontal upper portion of the steps. Okay, so this is your step. This is your one step. Okay, so this portion it is called as tread, which is the horizontal portion. Okay. So next definition is second definition. It is a riser. Riser. This tread it is also called as T is the nomenclature used for tread normally. For riser R. Okay. So riser, this is the vertical portion of the step. Riser is nothing but riser is this is this is the this is the vertical portion of steps. Riser is the vertical portion of the steps. Again, if we see the same diagram, okay, so here it is your riser and this is straight. So this portion we called it as a riser R. Okay. This portion is nothing but a riser. Next thing is winders. Okay. So the next thing is these are called as winders. Now what is the meaning of winders? So I will write here. These are the steps. These are the steps. These are the steps used for changing the direction of stairs. Used for changing the direction of stairs. Okay, so these are also steps, but these steps are used to change the direction of the stairs. Okay, in day-to-day life, when you visit any structure or anywhere, you will find these winders, especially when the space for the staircase is very congested, or uh, we have designed they have designed the staircase in a less space. At that time, when you are taking the change, that is, so at that time, when you are changing your direction, there is one what we can say incline step is there, or that step is not properly horizontal. If you see the step is normally, if you see from front view, the step is normally in this way. Okay. You will see the steps like this, and that step is somewhat like inclination. Some inclination may be there, will be there. Okay. And then if you once change the direction, then stair will continue like this above. Stair will continue like this. You will go up. So this staircase which is used to change the direction, it is nothing but winder. Okay. I hope now you clear with this what is winder. Now the next thing is fourth definition, that is landing. Meaning of landing. Okay. So this is a horizontal platform. Landing is this is a horizontal platform. Horizontal platform provided provided at the head of series of steps. Okay, provided the head of series of steps. Okay, so generally what is landing? So if we draw the diagram over here, suppose now this is the staircase, this is the thickness of the wall. Okay, or otherwise I will simply draw the line diagram for this. I will not show you the thickness over here, that we will see later on. So here now if you see the landing is, pay attention over here. So if you see this portion now, again if you see the staircase in the plan, it will be like this. Okay. And here the number of steps will be there like this. Okay, I will, this distance will be same, huh? My drawing is not that much good. This is dog leg staircase, what is I am drawing. Okay, and now from here these are the dotted steps, because if you enter from here, then this is the another flight. Two flights are there in the dog-legged staircase. So this portion is when you start climbing from here. Okay, so these are the series of steps. After this series of steps, this portion it is called as landing. Okay, if it is at the middle, then it is called as mid landing. And again from here you will change the direction like this after this landing, and you will move up. Okay, this is, here it is your second floor or first floor, whatever it may be, and this is your ground floor. Okay. So this portion is nothing but landing. Whatever the portion shown over here, this is landing. Okay, so I think you have seen this. This is very easy, so I am not going into much more detail. Then last definition is flight. Fifth one, it is flight. Meaning of flight. This consists of this consists of series of steps, series of steps provided between the landings, between the landings. Okay, so if I want to tell you what is the flight, then what they have said, this consists of series of steps provided between the landings. Now suppose I will draw the line diagram once again. Suppose now this is the initial landing, and then from this point here it is the staircase slab, and from here again it is like this. Okay, so the steps are provided over here. So these are the steps. So what is the meaning of flight now? If you see, this is your landing, this part is landing, and if you start from here, that is if this is the ground floor, then this is called, also called as approach. Okay, this is called as approach. Now the distance between the two landings. Now this also considered as a landing, this is also landing, and whatever may be the distance between these two, this distance, this whatever may be the distance, this is called as flight. This is called as flight. Okay. Now if you see the previous slide, this is dog-legged staircase. It is consist of two flights. Okay, now so okay, so now after this initial definitions, now we will move to the next part. So some standard dimensions are there that I will tell you what are some standard dimensions. Then for standard dimensions for trade, dimensions for trade. Okay, so standard dimension for trade for residential buildings, for residential buildings, for residential buildings, it is 150 mm to 180 mm. Okay, for residential buildings it is 150 mm to, that is 170 mm. Sometimes it is 180 mm. Okay, then for public buildings, for public buildings, for public buildings it is 150 mm. Okay, so the dimension of the, sorry, I think some mistake is there. For residential building, I am telling you, I have written over here trade and I am thinking about the riser. So of that, I will tell you the dimensions once again. For the residential building, the trade is for of 250 mm to 270 mm. Okay, this is for trade residential building, and for public building, it is 270 mm to 300 mm. This is for the trade. Okay, so you have already seen this many of the times. Then this is the standard dimension for trade. Now standard dimensions for riser. Standard dimension for riser. Okay. So what are the standard dimensions? Now first residential building and then public building. Okay. So residential building. For residential building, it is 150 mm to 170 mm. Okay. Or sometimes you can take 180 mm also. And then for public building, it is 150 mm. For public building it is 150 mm. Okay. So these are the standard dimensions of trades and riser and trades. Okay. So the next thing is the minimum width of stairs. Okay, the minimum width of staircase Okay, the minimum width of stairs, don't not staircase. The minimum width of stairs, it is 850 mm. At least it should be 850 mm width of the stair. Then for the residential building, the minimum width is 1000 mm near about. Okay, so residential building, for residential building, minimum width is minimum width it is 1050 mm. This is for residential building. Okay. Then next is the headroom. Headroom over the stair shall be at least 2.1 meter. Okay. So we say this as a stair tower. Stair tower, or this is called as headroom. Headroom over the stair. Over the stair shall be at least at least 2.1 meter, which is 2100 mm. Okay, 2100 mm. The next is the loading. So live load for residential building, live load for residential building, live load for residential building, it is 2 kilonewton per meter square to 3 kilonewton per meter square. 2 kilonewton per meter square to 3 kilonewton per meter square. Okay, and then a live load for public building, live load for public building, it is 5 kilonewton per meter square. It is 5 kilonewton per meter square. Okay, so now we will see the dead load consideration of the staircases. So what types of load should be considered on the staircase as a dead load? Okay, so that we will take the now. So here I will give the heading dead load considerations. Okay. Dead load considerations. So what we should consider over there, that we are going to see. Okay. First is the weight of west slab. Okay, staircase वरती काय staircase डिझाइन करताना पहिल्यांदा तुम्हाला काय घ्यावं लागणार आहे, तर स्लॅबचं वेट घ्यावं लागणार आहे, weight of west slab. Okay, so I will write here weight of west slab. Now how it is calculated, weight of west slab? So it is always calculated for per meter width of the staircase. Okay, per meter width and per meter length of the staircase. So we will consider the width of the staircase as 1 meter, and then we will calculate the dead load, that is weight of the slab. So normally up till now we have in DCS-I also many times we have taken the weight of the slab. as a dead load. What we do there, we take depth of the slab and multiplied by 25. बरोबर आहे ना? बघू बघा, माग तुम्ही वन वे स्लॅब, टू वे स्लॅब डिझाईन केलेले आहेत, त्याच्यामध्ये तुम्ही वेट ऑफ स्लॅब कसं घेतलेलं आहे ते बघा. दिस इज द थिंग दॅट वी हॅव डन ऑलरेडी and I have told you why this should be taken. So it is d into 25, where d is the depth. Okay, so d is to 25, but this thing is for the horizontal slab. Okay, but if you see, the staircase slab is not the horizontal slab, it is inclined slab, which is inclined at an angle theta. So we need to consider one term for this inclination, and that is we multiply this quantity into under root here r square, that is riser square, plus t square, r square plus t square whole divided by t. Okay, so this is the quantity which we are going to consider. This is the term. Okay, this is the additional over here due to the inclination. Okay, due to the inclination. ते जे incline होत आहे ना, त्या incline मुळे तसं येणार आहे ते. Okay, are you getting my point? Here it is, it should be, or instead of this, if you don't want to take this term, then you should multiply it by cos theta. You should multiply it by sec theta, not cos theta. 1 upon cos theta will be there. हे येतं कसं तर बेसिक जे आहे थोडंफार तुम्हाला सांगतो, एक्सप्लेन करतो. So here if I draw the line, then see, I am drawing one step. Okay, now suppose this is your step. This is what? This is trade. This is riser. Okay, and now this is your hypotenuse. Then this will become under root r square plus t square. This angle is 90 degree. This angle is 90 degree. And if you see the stair, okay, now if this angle is theta, this is the west slab. This line, this is nothing but your west slab of staircase. Okay, west slab, that is inclined slab, and this is a single step. This is again trade, this is right. If this angle is theta, then this angle also, it will be theta, correct? So this angle will become theta, right? Now if you calculate the cos theta over here, then cos theta, what do we get? Cos theta is equal to adjacent side, okay, that is t divided by under root r square plus t square. This is for the cos theta. Okay, this is for the cos theta. Now what we are doing, we have here calculated the horizontal weight. So we have calculated the weight in horizontal direction. Okay, horizontal direction. If we multiply d by 25, we will get weight in horizontal direction. But already for the horizontal weight, we are making it inclined to some angle theta. We are making it inclined to some angle theta. So we need to divide this by cos theta. Suppose now if you get this weight as I will say here W. So if we want to shift this weight to this inclination, then it will be W divided by cos theta. W divided by cos theta. Okay. So in this way now we will get this. If you divide the W by cos theta, then it will be T divided by under root r square plus T square. So this r square plus T square will move upward, and it will be under root r square plus T square divided by T. This will be the final thing you will get. Okay. So this is the thing where you can calculate the load. So in this way, the weight of waste slab can be calculated. This term you need to consider because of this inclination. So this is the first thing. I hope now this formula I have written over here. You write down this formula. Okay, you write down this formula. Yeah, this quantity is per meter width and per meter length also we will consider over here. Okay, and after that we will design. So now next thing is weight of each step. Second, now this is the waste slab is over. Now second is weight of each step. Okay, weight of weight of each step. Per meter running we will calculate the weight. So to calculate the weight, the formula is, it is very simple, R by 2 into 25. This is the formula, or you can say here 1/2 into riser into 25. So this you will get in kilonewton per meter. Per meter run, per meter weight, we will calculate the weight of each step. Okay. So half into R. This is the formula. Now third thing. Third is the floor finish. It comes under dead load. Floor finish. So what is the value of floor finish? It is generally 1 kilonewton per meter square to 1.5 kilonewton per meter square. Okay, so if we consider the per meter length, then we will all directly take it as 1 kilonewton per meter and 1.5 kilonewton per meter. Generally, we will take it as 1. Okay, so for if we want to take this for considering the 1 meter width, and if we take the per meter length, then we will always divide the each term by trade. Okay, so now the main thing over here is sometimes they don't give you directly the floor finish. In the examination, sometimes they tell you the material which they are going to use for the floor finish. That is, suppose the granulithic floor finish, and the density of that is given to you. Okay, so in that case, you need to calculate the floor finish. How you are going to calculate? You will take the thickness, whatever given, and you will multiply that thickness by density. So you will get the value of floor finish. Okay. So the next thing is the depth of the west slab. How to assume the depth of the west slab? Initially, as you know that now in the design you are familiar with the design. Initially, we assume something, and after that we will take the check for that. Okay. So depth of the west slab. Depth of west slab. Okay. So how to assume the depth of the west slab? So here we are going to assume it, that is 40 to 50 mm per meter span. Okay. So I will write here it is assumed it is assumed 40 mm to 50 mm per meter span. Okay, I hope now you are clear with this, how to take the weight. Okay. what does it says now? Depth of the slab. So suppose now I want to calculate the depth of the slab. What we have assumed, 40 mm to 50 mm per meter span means what? For 1 meter it is 40 mm. For 1 meter it is 40 mm. If we take 40 per meter span. If the span is 2 meter, then we are going to take it as 80 mm. Okay, and likewise we are going to take the depth. Okay, suppose the span is 2.5 meter. So 2.5 into 40, whatever may be the answer, you are going to take the overall depth of the slab. Okay, so in this way, we are going to take the consider or assume the depth of the slab. It is in between 40 to 50 mm. We are going to assume. Then after this, bending moment. So the bending moment in the staircase slab is generally WL square by 8. Span we are not consider the inclined length for the span. We always consider the horizontal length for the span. Okay, and for the slab also we calculate the horizontal load, and we will shift that horizontal load to the inclination, because in actual practice it is what we can say inclined. But while considering the span or effective span, we will consider from plan, that is from top. We will not consider any inclined length for the span. Okay. So now how to calculate the effective span of the staircase? There are three cases, and some clauses are given in the IS code. So we will see those clauses and the effective span. How to calculate the effective span for the staircase. Now this is the loading, that is dead load. A live load I have already told you, that is 2 kN per meter square to 3 kN per meter square for residential building, 5 kN per meter square for public building, and these are the three loads, that is weight these two are the live loads. Then in the dead load, weight of west slab, then weight of each step, then floor finish you need to consider over here in the dead load. And one assumption also we are going to make while calculating the depth of the slab. And depth of the slab we are going to take 40 mm to 50 mm per meter span. So this is the loading and depth. Now after that we will see how to calculate the effective span of the staircase. Okay, how to calculate the effective span of the staircase. So now for the effective span, so I will give the heading over here, effective span. Effective span. So first, when the staircase is supported, now write down, this is the important boundary condition. So note it down. When it is staircase is is supported, when staircase is supported at the end at the end of the landing slab, end of the landing slab, then then effective span equal to the effective span equal to the going of stairs, going of stairs plus plus at each end at each end either half the width of landing at each end either half the width half the width of landing or 1 meter or 1 meter whichever is smaller whichever is smaller. This is the condition what they have told you. So when staircase is supported at the end of the landing slab, then the effective span is equal to the going of stairs plus at each end either half of the width of the landing or 1 meter whichever is smaller. So I will tell you this by drawing a diagram so that you will understand it. So now suppose now this is the west slab. Okay. I will take the different color. So now this is the west slab. Okay. So now landing. I will draw here landing. This is the landing at the top. And this is the approach, or this is also called as landing. So from here you will start. Okay. And the steps are there on this portion. So I will try to draw the steps. So these are the steps. Okay. Now what does it say? Effective span. Okay. So effective span means what? Suppose now consider this length, this total length from this point, okay, this point to this point. Suppose this total length is 2y. Okay. Normally what we assume? We assume x, y, a, b, c. A single letter we assume over here. Let us assume that this length is 2y. Okay. And similarly assume that this total length is 2x. Suppose this total length is 2x. Okay. Now if I take the center, now if I take the center of this, okay, center of this point, here is the center and center of this also. Okay. Now if I go at the center, then if this total is 2y, then this much will be y, this remaining also y. Okay. Similar thing is there. If this total is 2x, then this will be x, this is also x. Okay. So now this is called as your going length. हे जे आहे या पॉइंट पासून ते या पॉइंट पर्यंत. This is called as going length. Going length. Now what does this clause say? And this is, by the way, I am telling this, this is from the clause. You can refer clause number. This is according to clause number 33.1. Okay, it is given on page number 63 of IS 456 2000. IS 456 2000. Okay, you can refer there also. So now what does it says that going length? Going length means what? Length from this point to this point. Okay, now if I extend this, if I extend, so whatever may be this length, this is called as going length. I will use the notation as. Here you see this word. Okay, going of stairs. Going. Okay, so I will write here going length. गोइंग लेंथ किती आहे तर यस. मग आता मला इफेक्टिव्ह स्पॅन घ्यायचा आहे ना. आय वॉन्ट टू कॅल्क्युलेट द इफेक्टिव्ह स्पॅन. सो द इफेक्टिव्ह स्पॅन इज फ्रॉम दिस सेंटर to this center. Okay, this center to center is nothing but effective span. Okay, so this is nothing but effective span, this center to center. So now if I want to calculate the effective span, then I can write over here L effective is equal to this is the going length S plus half of this length and half of this length. So it is plus X plus Y. Okay, हे कधी येणार when x and y are less than 1. Okay, when x and y are less than 1, then only you can use this s plus x plus y. Okay, if more than 1, then take it as 1. Okay, if the value of x or y is more than 1, then take that value as 1. Here it is the value of x and y. Okay, so this value should be less than 1. Then you can take here while calculating the effective span. Okay, now we will understand this with the help of some values so that it will be easier for you to understand this. Now suppose this going length, this s is now, suppose this is 4 meter, assume that, and now this 2y, this landing length, suppose it is 1.5 meter. Okay, suppose it is 1.5 meter, and suppose this length it is 1.2 meter. Now what will be our effective span then? Then L effective in this case, if I want to calculate, then see, this is the going length. This going length is 4 meters, so I will write here 4 plus. Okay, now this total is 1.5. So the value of 2y is 1.5. So half of this, it is how much? 0.75. So 0.75 is less than 1 or greater than 1? It is less than 1. So I will consider here 0.75 for the value of y. Then again 1.2 meter for this side, here 1.2 meter. So now it is equal to 2x. So what is the value of x? Half of this. So it is 0.6 meter. Okay, so 0.6 is, I guess, greater than 1 or less than 1? It is less than 1. So we will consider here 0.6. If it is greater than 1, then we are going to consider 1 only, 1 there. Only 1. If this value of x and y should not be greater than 1. That is what the clause says. So here if you take the total effective span, then this is the your effective span. Okay. Now while solving the problem, we will see it in the detail also. Okay. Now understand this much. What is this? This is sufficient if you understood. Okay. So this is for the effective span for case number 1. That is which case? The important thing is when the support is provided at the landing. So here the support is provided. Here at this point and here at this end point. At these points the support is provided. Okay, here and here. When at these points the support is provided. So this is the thing. Effective span. So for the next, now see here the support is provided at the end. For next case is when support is provided at here only. इथं कुठेतरी support provide केलेला असेल. So I will show. Now in this case the support is provided at the end of the landing slab. So we are going to take the effective span is like this. Now if the support is provided here only, at this point one support is given and at this point second support is given. Instead of these two, if I shift this support from this point to this point here, and similarly if I shift this support from this point to this point, then your support will be at these 2 points. Okay, so in that case also how we are going to take the effective length, that I will tell you now. So another point number second. Okay, what does it say? When supported at the top, see when the staircase, it is when staircase is when supported at top supported at top and and bottom risers. Now see this word, risers. Then the effective span is this distance is the distance between center to center of support. Okay, so again we will draw the diagram. So these are the west slab of the staircase. Okay. So again landing, then this is the approach. Okay, so we will close this. You can also show section over here, section line, cutoff line. So now support is provided at this point. Now here the support is provided. Here the support is provided at this point. First support is over here, second support it is provided here at this point. So now this type of case is there. Okay, usually this type of case is there. Then what is your effective span? Now if I draw the center line, this is the center to center distance we should take. Okay, if I draw the center line, then whatever may be this total distance, okay, this total distance from this point to this point, this total distance, this is nothing but this is your effective span. This is your effective span in this case. Okay, is it clear now how to provide this? Now in this span also, in the examination, to confuse you, they will also provide the support here. Here also some support will be given in this, like this way. Okay, in this case also you have to take the effective span as I have told you, like the same way. Now these supports are provided here also. This is point 1, point 2, and here also they can provide the support. So if these types of supports are provided, this type of system is there, then the effective span is between these two. And if these two supports are not there in the previous case, like now we will draw the supports. Suppose now the first two supports are provided over here. This is the one support and this is another one. So in this case now we have already seen how to take the effective span. Okay, again if I draw the dotted line, that is center to center. So from here, okay, if it is like this, then your effective span is from this point to this point. This is your effective span. Okay, this is your effective span. And in examination, to confuse you, suppose they have provided you two additional supports. Okay, two additional supports like this here also. Now you will get confused if these types of supports you will see. You will be in a confusion that whether to take from this center to this center, or from these two supports. Okay, so don't get confused in the examination if this type of question is there. Even though if this type of condition is there, here the supports are provided at this point and at this point. Okay, so we have to take the center to center of the support only, even though the diagram is like this. And you know, previous case, when suppose I will give the name point number 1, 2, point number 3 and point number 4. So if the support is given at point number 1 and point number 2 only, then also your effective span is in this like this. If the supports are provided at point number 1, 2, 3 and 4 at 4 points, then also your effective span is remains same like this. Okay, but if the support is provided only at point number 3 and point number 4, that is at the end of the landing, not provided at point number 1 and point number 2, then your effective span will be in the previous case, whatever I have told you, s plus x plus y, where the values of x and y should be less than 1. If it is greater than 1, then the maximum value you should consider it as a 1. Okay, it should not be greater than 1. So in this way you need to consider the effective span. Okay, that there is one more thing. When the landing slab span third thing is, when the landing slab spans in the same direction as the stairs and they should be considered as acting together, then it is considered as a single slab. Then the effective span is center to center distance between the supporting beams or walls. Okay, so if the support is not given only at the end, so the third thing is not much more complicated. Third case, there is no need to go for the third case. You remember these two, and while solving the problem, I will tell you how to take the effective span. Okay, so now for today, I think this much is sufficient.